This is our video for EA9 and our pre-lab for the rubber band stretch lab. EA9 is about precision and accuracy. We need to recognize that these are not the same thing. If you don't know the difference, you'll refer to them as the same thing, and that's not correct. So we need to think about the difference now. First of all, precision, the word precision or precise means how specific a measurement is, or how many decimal places are written. We'll go over that a little bit more down here in EA10 using decimal places correctly. So you may want to, we'll fill this space, but you may want to pay attention to this being discussed more down here. Accuracy, on the other hand, accuracy means how close a value is to what others agree is correct. This word correct, you may think means both of these words. You might think precision means correct and accuracy means correct, or precise means correct and accurate means correct. That's not, in fact, the case. Accurate is a better word to describe whether something is correct or not. To get this, I want to refer to an example from a dart game. If you imagine playing darts against some other person, we could imagine playing darts against someone and say, this is your dartboard, this is your bullseye. We're trying to get it in the bullseye. And let's say each one of these dots is your darts. I'm drawing my dots very, very carefully, and I'm saying that, okay, imagine you get these darts near the center, near the bullseye, but they are spread out from each other. Notice, like, maybe you don't quite get any bullseyes, or maybe you get one bullseye, but the dots are kind of spread out from each other. We would call this accurate, that is close to the bullseye, but not precise. We're saying they are close to the bullseye, but they are not close to each other. That is, like, you're not getting all those darts close enough to the bullseye for us to say, like, yeah, that's accurate and precise. On the other hand, you can imagine, like, let's say you had some dart throwing machine and it was set up wrong. So you've got this same dart game, and this dart throwing machine gets all the darts really, really close to each other, but nowhere near the bullseye. So we could call this darts close to each other, and not near the center. We would describe this as precise, but not accurate. That is, if we think of accuracy as correctness, these dots are not close to the bullseye, the correct place to get your darts. So we're saying these dots are not accurately thrown. These dots over here are more accurately thrown, but they are farther apart from each other, so they are less precise. So now that we have an idea of how the words precise and accurate are used, we're going to want to try to actually use them with an example. You know that these meter sticks have 4 sides to them, and you've seen those 4 sides. I want to show you what makes them so different. Obviously, this side says 1 meter, and we can't tell all that much with this side. That is, we know that the Arizona iced tea bottle is less than 1 meter. We can't tell all that much more than that. But if I turn the meter stick this way, you can see that that 1 meter is split up into 10 parts. Each of these is a tenth of a meter. So this would be 0.1 meters, 0.2 meters, 0.3 meters. If I hold the iced tea bottle up against this, I can tell, okay, that's more precise. I can say that the Arizona iced tea bottle has a length of 0.2 meters. So I'll say length equals 0.2 meters. You don't have to write this down in your notes yet, just pay attention to that number that I just wrote down. Now, if I turn the meter stick over again to here, you can tell that these numbers have even smaller divisions. That same length of a meter is split up into 100 parts. These are called centimeters, but we can also say like each of these is a hundredth of a meter. So this would be 0.01, 0.02, 0.03, and so on and so forth. I can use this side of the Arizona iced tea bottle to make another measurement. If you look at that carefully, you'll see that the top of the Arizona iced tea bottle comes out to around 22 centimeters. So I know more detail about the length of the bottle. I can say that the length of the bottle is 0.22 meters. It is 22 hundredths of a meter. So I could also write down length equals 0.22 meters. This number isn't wrong. It's not inaccurate. Both of these numbers are accurate, but this number is more precise than that number. Going one step further, you'll see this side of the meter stick has millimeters marked on it. That is, a millimeter is a thousandth of a meter. So this same meter is split up into 1,000 parts. I can measure the length of the Arizona iced tea bottle with this side, and I can tell if I look really, really, really closely that you're probably going to read this better than I can, but I think that it says about 0.216 or so, a little bit more than 0.215. That is, I could also say the length of the bottle is equal to 0.216 meters. Again, these numbers aren't wrong, they're just less precise than this number. This is a very precise measurement because it has so many decimal places. They are all accurate, but this number is more precise than these two. So now that you've seen an example of this, we want to actually include this example in our notes. You need to think about how many decimal places you write. In some situations, an answer is only correct if given to a certain precision. Some questions will ask you, write your answer to the nearest hundredth of a meter or whatever. We need to pay attention to that. And we just saw this in the example about the length of the bottle. So we're going to say this is an example. I'm sorry, we're going to refer to this as the length of the bottle example. And we said that it could be written as 0.2 meters, 0.22 meters. This is the same as 22 centimeters, but we're saying like that's a more precise answer. Or we could even write 0.216 meters. We're saying that all of these measurements are accurate. All of these measurements are accurate. They're all correct, but this one is the most precise measurement. That is, it has the most decimal places. So when we say make sure that you write down a precise answer, we're not saying get the answer right, we're saying write down a bunch of decimal places. This is especially important when you think about how to round your answer. You guys saw this earlier when you're calculating slopes. In science class, 4 centimeters over 3 kilograms does not equal, say 1.33333 centimeters per kilogram. A lot of people are asking, like, hey, do I round this? That would be like saying, if we think of this as 1 centimeter, 0.3 centimeters is 3 millimeters. 0.33 centimeters is 3 millimeters and 3/100ths of a centimeter. That is like a tenth of one of these tiny, tiny, tiny things. 0.333 is 100th of one of these, sorry, 1,000th of one of these tiny things. That is, if you're writing down all these decimal places, that's the same as measuring to 1/1,000,000th. Sorry, 1/1,000,000th of a centimeter. So the big idea here is to round answers to a reasonable decimal. Don't leave your answer as a fraction. Don't leave your answer with a bunch of decimal places like this. You need to round answers to a reasonable decimal, never a fraction. The reason why we never write a fraction is that's kind of implying that we know that precision down to like a very, 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 very specific value, when in fact we need to write it as a decimal and then think about how much of that is reasonable. So if you want to make a note to yourself, this is probably the only amount of that number that's actually reasonable.